Welcome everybody to today's panel on building Bitcoin's future, smart contract scaling and interoperability. Let's start with a brief round of introductions. I'm Felix from Greenfield Capital, a European crypto asset management firm focused on DeFi, consumer and infrastructure.
Yeah.
Please
Hi.
introduce your project briefly.
Hi, everyone. Good afternoon. I think it's afternoon. My name is Mosh. I work on partnerships for Boundless by Risk Zero. I'll be deep diving a little bit more into what we do a little bit later.
Hey guys, nice to meet. I'm Yogi. I work at Mezzo. We're a Bitcoin L2 founding contributor. Excited to be here.
Hi, everyone. My name is Andre. I'm the head of product at Bitcoin L2 Labs. We're a core development company in the Stacks ecosystem, so we work directly on the Stacks blockchain, and we're also building SBTC.
Hi, I'm Iago. I work on Bitcoin OS. Bitcoin OS is an operating system for Bitcoin and crypto, which allows Bitcoin to become a fully programmable layer and allows the rest of crypto to directly and trustlessly integrate with Bitcoin.
So let's dive in. So Bitcoin has historically prioritized decentralization and security, while other ecosystems have focused more on speed and experimentation. And how can Bitcoin scaling solutions as they grow balance innovation with the principles that make Bitcoin unique? And how should we as an industry handle that?
Yeah. Okay. Yeah. I can go a little bit more into what Boundless is by Risk Zero. So, for those of you who may not know, Risk Zero is the team that is building more general purpose ZK infrastructure, and Boundless is our universal proving protocol. So, we are essentially building a protocol that is focused on unlocking ZK and bringing ZK to every chain and every ecosystem, including Bitcoin. Initially, one of our problems that kind of led us to building this protocol that we've identified is that in the traditional model for networks, you essentially have every node redundantly processing every transaction. So you're essentially limited by your slowest node when it comes to execution. And this basically means that you can only do simple computations. You can't do complex computations. So Boundless is essentially our solution for ZK-fying that entire process and having every node basically provide execution proofs, and then you can verify those proofs on any network, including Bitcoin. The way that we really see Bitcoin and ZK, and I like to call it, is Bitcoin and ZK are kind of like twin flames. We have basically the same kind of priorities when it comes to security and decentralization. And there's just a huge natural fit. So when we're kind of looking at Bitcoin, we're really noticing that a lot of BTC L2 teams like Bitcoin OS, Bob, as they're thinking about their stack, ZK is becoming a really important piece of their stack because it allows them to, preserve Bitcoin's core security while treating Bitcoin as the settlement layer, but then offloading all of that complex execution and bypassing all of those gas limits through the Boundless network. So that's kind of how we're positioning ourselves when it comes to supporting Bitcoin innovation and Bitcoin scaling.
So I'll continue from there. Thank you.
Yeah.
I think that's a good introduction to what we're doing. So there's this challenge that we have, right? On the one hand, we want something which is as decentralized, permanent, reliable, and trusted as Bitcoin. On the other hand, we want to be able to build systems which are as fast, as frictionless, as seamless as Web 2, right? The kind of applications that we're all used to using. And what I think we've seen from crypto up until now, what we've seen from every single blockchain, sort of smart contract blockchain up until now, has been a necessity to compromise where you get neither of these things. You end up somewhere in the middle, right? You're not as secure and reliable as Bitcoin. You're not nearly as fast as Web 2. And so the problem has been the technology available to us up until now. And because of work like what Risk Zero have been doing, and because of the absolutely astounding progress that we've made in ZK, both in terms of what you can do with it and the cost of computing, the time to compute, and because of the work that is now that we've been spearheading with Bitcoin OS, which allows you to actually verify ZK on Bitcoin, you can actually have the best of both worlds by following a barbell strategy, right? You use Bitcoin, the ledger, as the ledger, and then you can build applications which are like Web 2 applications, but are completely verifiable, completely provable and execute on Bitcoin. So all of the computation, the heavy stuff, is kept off chain rather than being shoved into the chain. And now you can have the best of both worlds. And what this does is it allows us to sort of mediate based on the kind of application that we want to be using, what kind of system we want. If we're doing gaming, probably can run on a single verified server, like a massive server, right? But it can be extremely fast. If we want to be doing DeFi, then we might want to have a system with multiple validators like Stacks, or Meso. And this is also one of the reasons that we're integrating with Stacks. And there you can have truly immutable, irreversible transactions, which are uncensorable as well. And so where we are now is we're starting to see sort of like the borders between these different systems begin to dissolve. We can use Bitcoin as the settlement mechanism for the entire crypto space. And every single developer will be able to figure out, like, what is the security assumptions that I need to build? What is the trade-off that I need to make? But in all of these cases, they'll need to make far fewer trade-offs than they've had to do up until now.
Yeah, I can build onto that for a little bit. Like, the way that I like to think about this is that when you're building distributed systems, you really want the base layer to be as secure and resilient as possible. I think that's why all of us on this panel, or many of us on this panel, are building on Bitcoin. And ultimately, it's the layers on top of Bitcoin where you can start to see a lot more of this experimentation and innovation. It's why at Stacks, we're focused on having highly scalable transactions and more programmable smart contracts to actually unlock this capabilities on Bitcoin. And so you really want the layer 2 networks on top of Bitcoin to be where the experimentation happens, to be where the innovation happens, ultimately can ideally settle down to Bitcoin and inherit many of the inherent value properties of Bitcoin in terms of its security and censorship resistance.
Yeah, I think to add from like Meso's perspective, for us, there's like two approaches, right? There's like an academic approach of how we think about the space, and then the economic approach. And I think for us, Bitcoin itself is a very safe and secure asset. I think no one disagrees with that. And the way that we've built our infra, just because there's nothing really active yet, we have a lot of discussions on BitVM, we have OPCat, we have a lot of people trying to figure out ways to execute on Bitcoin, as well as, Bitcoin OS working on ways to do things. What we've done is we're a side chain. We don't really like the term L2. For us, it's how do we take this asset that's really sound, and how do we have it participate in the economic system? So we used to call ourselves last year like the Bitcoin economic layer. And so the idea for us is we have a bridge called TBDC. It's a forward security model, 51 out of 100 signer network. It's a two-way bridge from spot Bitcoin to EVM Bitcoin. And then how do we basically build a cultural economy around it so that you can basically like force function it being a participating asset? Because if you look at BTC on EVM and elsewhere, you have a little under 1% of BTC on chain today, and even less of that is actually participating. And you can look at the yield rates on Aave and Compound, or whatever you want to look at, just to see how much of it's actually utilized, and it's pretty low. And so the mind for us is what's easy, what do people get? And so with that, it's how do we get TBDC to get people on EVM? And then how do we make it a core asset? And one thing that we're pushing, which we, I believe yesterday, put out a blog post on MUSD, which is going to be a Bitcoin-backed stable. So like instead of selling your Bitcoin, how do you borrow against it? No cap gains for any Americans in the room. And use that as a way to use it instead of like BTC in itself, because we've seen that people don't want to spend their BTC. So how do we unlock that like niche use case? So it's kind of how we're thinking about it.
Cool, thanks a lot. You guys touched upon it already a little bit regarding scaling solutions, L2s, rollups. What in your mind are the unique challenges to actually implement rollups and ZK technologies on Bitcoin? And what are the unique strengths of Bitcoin that should be maintained, and what should be covered by the Bitcoin network itself? And what are aspects that should rather be outsourced to external participants, external networks? And I'm thinking specifically about data availability here. I guess it's possible to post some data, but it's very expensive on Bitcoin itself. So yeah, what are your thoughts here?
I think it's exactly that. The one thing that you're probably not going to be doing on Bitcoin is data availability, which is basically storing the entire list of all the transactions that happened. What ZK proofs do is they aggregate those transactions. So you'll have thousands of transactions occur at potentially very, very high speeds, instantaneously, low cost, and then you'll aggregate them into a single proof and write them to Bitcoin, and then they become Bitcoin transactions. The one thing that would be missing in terms of the security assumptions is having you want people to be able to sort of look at that proof and know sort of which transactions it refers to. And so you need some kind of data availability layer where you write that. I think that's the big disadvantage with Bitcoin. We're probably never going to see that on Bitcoin itself. There are data availability layers being built for Bitcoin. The big advantage that Bitcoin has is that if you look at the overall landscape of crypto and blockchains, Bitcoin is the one system which is truly a pure play ledger, which is what you actually need for this. A system where you can, like, that's where you write the proofs to, without sort of all of the overhead that smart contract chains have built out. And that gives it a huge advantage in terms of reliability, in terms of the fact that it never needs to fork, and actually in terms of sort of like the speed for your computer to process the transactions that are occurring on Bitcoin.
Yeah, and I can kind of add a little bit to that as well, because at Boundless, like we're kind of on this fringe, right? We're essentially facilitating, settlement on Bitcoin, settlement on Ethereum, Solana. So we have a little bit of an outsider perspective as well. It's been really fascinating for the past year as I've been like following the Bitcoin space so closely. Is that the entire space is like actually aggregating or converging towards this urgency to enable flexibility of these assets, as Mezzo and Stacks is working on, and Bitcoin OS as well. And where we really see ourselves is that while we are aware of like the data availability kind of constraints and kind of issues, we also want to ensure that we can stay as a modular kind of solution for you guys. With Boundless, like, as I mentioned, like a big piece of Boundless is essentially unlocking all of this execution. So you can do your proofs, you can settle those proofs on top of Bitcoin, and then you can like verify them from any chain or any network. But on top of that, we also take care of the aggregation, we take care of the settlement, and that means that we're actually ensuring that we're basically creating this stack. The big piece about this stack is that it's not an L1 or an L2. Like Boundless isn't an L1 or an L2. We want you guys to run the L1, the layer 2 scaling solutions. We essentially want to be a set of smart contracts that you can deploy anywhere, whether that's on your L2, whether it's on Bitcoin, anywhere in the space, and basically be able to access and verify these ZK snarks. And when it comes to like DA, I think a big piece about this is like being able to allow you guys to like essentially hook up to the DA providers that you want to use. So we've been obviously, supporting Celestia DA, Eigen DA. I know that there's a team in the space, Syscoin, that's also exploring their own version of the Bitcoin DA as well. So being able to kind of be this flexible, extensible player in the space and have you guys kind of contribute to the protocol and customize it to your needs is really how we see ourselves in supporting you in this mission.
Yeah, I think that's really well put. So yeah, just to kind of like recap a couple of things here, I think that the biggest challenge with Bitcoin today is that it doesn't have the ability to verify off-chain computation. And so if you're building a layer on top of Bitcoin, it's really hard to do that without introducing additional trust assumptions. And so really, we're looking at ways that we can enable additional programmability and functionality to Bitcoin while minimizing those sorts of trust assumptions. I think that's clear that Bitcoiners don't want to introduce new security or trust assumptions in these models. And so with Stacks, we've built a model that's built on threshold signatures. We have a decentralized network of validators that are responsible for securing the Bitcoin and approving deposits and withdrawals of Bitcoin into and out of the system. And those ultimately are able to settle to Bitcoin through a hash of those transactions. I think at least the way that I've looked at this is that Bitcoin ultimately won't have the ability to verify that computation unless there is a fundamental change to Bitcoin to introduce these new opcodes, right?
So actually,
so at least the way that I've looked at it, right, is like you need something like opctv or opcat to be able to introduce covenants and vaults onto Bitcoin. So I'm curious to understand more about how you guys are really doing this without having that more expressive programmability with Bitcoin today.
So yeah, so Andrew, this is really, there's so much happening in the space. It's really interesting. So as it turns out, we're actually working with some people on Stacks right now to integrate work that we've done or allowing for ZK verification, right? So the Stacks have built out one of the more decentralized bridging mechanisms using the threshold mechanism, which has a trust assumption, a majority trust assumption, right? That means you need to have the majority of operators behaving in a trusted manner for the funds not to be lost. And then this extends to any other more complicated thing, like if you wanted to have a smart contract built on Stacks or any other execution environment, but executing on Bitcoin, then you would have that trust assumption as well. And so things very, very quickly fall down. We had a great example of this recently, which is Bybit, right? Which they had this multi-sig basically through Nostr Safe, and $1.5 billion were stolen. Turns out today we learned that the exploit was not on Bybit. The exploit was on the servers of Safe, who were running the actual software itself. So we have a very, very deep problem if we're stuck with majority trust assumptions. So what has changed over the last 6 months for Bitcoin is we now have the ability to have ZK verification with a totally different trust assumption. And this trust assumption is what we call a one of n trust assumption, or what that actually means is that unless every single participant is actively exploited, right, the system maintains its cryptographic integrity. This basically means that so long as the system is working, right, no bug has been introduced, the system is cryptographically trustless. And that's where we want to get with Bitcoin. We recently introduced a testnet version of this, which is now integrated with Ethereum, is integrated with Merlin, is integrated with a whole bunch of different Bitcoin Layer 2s and EVM chains. And the work is currently happening with you guys to allow Stacks to also operate in that way. And this is going to be a major evolution for Bitcoin, because instead of having to rely on these trusted setups and these trusted multi-sigs and threshold mechanisms and a whole bunch of assumptions like that, we're going to be able to do what Bitcoin was designed for, what crypto was always designed for, have cryptographic assumptions which can allow us to achieve effectively cryptographic type trustlessness.
Yeah.
If I may interject, Felix, just asking a question, because this is really fascinating, right? So from the ZK side of things, what we've mostly seen has been BitVM teams, right? That's like the easiest way that teams are kind of building I like to call it trust minimized bridge, because it's essentially like you have the EVM consensus like client on the Ethereum side, and then you have the Bitcoin ZK like client on the Bitcoin side. How is like the BitVM implementations and the variants of BitVM implementations? I'd be really excited to hear from you, Andre, like different from Stacks' like threshold mechanism.
Well, I think, to be clear, we're also really excited about the one of n security assumptions. I think that's where the industry is ultimately headed. But as of today, it's still in sort of an R&D phase. I think some of the questions that I have around it are around how do you implement this in a way where the user experience is good enough to a point for the majority of users. So my understanding of where BitVM is today is there's still a lot of liquidity constraints. There's questions around how do you incentivize those sorts of the operators to provide that liquidity. And so I think that is the goal. Like, we want to get to a place where basically if anyone is running a node, you have the ability to verify that that transaction is going to be correct and that the Bitcoin is being returned to your address. But I think right now there's still implementation details that we have to work out for that.
For me, the way I'm kind of understanding it is like the one of n assumptions mechanism is more about like how do you unlock like liquidity much more easily from the native layer, right? Because like basically fielding all of that liquidity for like the BitVM teams, you have to, it's kind of like how Babylon has to set up all of these different like institutional like funds to stake that on the Babylon layer and then bridge that over and use a BitVM bridge to like bridge that over.
I think specifically what I'm talking about here is that in BitVM, you have operators that have to front the withdrawals of the Bitcoin. And so they are basically, and then they go out and essentially get reimbursed from the model once I believe it's about a week period has passed.
It's similar to like a solver protocol almost.
Right. And so looking at like how can we implement that in a way that is capital efficient, I think is going to be a big piece that we still need to sort out.
That's awesome. I learned something new today.
Regarding the one of n trust assumption, to what extent would you say like that's sophisticated actors or even not so sophisticated actors can just run the equivalent of a full node themselves, and then they're the one of n, and so it's completely trustless from them? Is that an analogy to make, and is that feasible?
So It depends on the design. Right now, for example, with Bitcoin OS, the system that we're using, BitSnark, it has some limited number of N, right? Depending on the setup. What we're already beginning to work on is sort of V2. In V2, there is an unlimited number of verifiers. So N is infinite, potentially, or basically N can be every single user. And one of the reasons that it can be every single user is because ZK Lite clients mean that you basically get the security of running a full node, but you can get it by running an extremely light client, which could even fit on a phone. And so I think, projecting forward over the coming months, we're going to be looking to upgrade to anyone can verify, and certainly I suspect that over the next couple of years, the entire industry is going to that is working on sort of one of N systems is going to be looking to move to anyone can verify systems.
And what about, I guess, systems that are less tightly integrated with Bitcoin, maybe side chains, other ecosystems? What are the challenges to integrate with those? I mean, we were talking about, I guess, threshold schemes. You have these kinds of bridges. Where are we headed there, and what are the unique challenges for Bitcoin that has been rather, I guess, isolated from the get-go, like designed to be kind of standing on its own?
Yeah, I guess I think from our perspective on the we have a DAO, Threshold DAO, that manages TBTC and the bridge there. And I know our engineering team has been closely watching the development. So it's really keeping an eye on which of these is scalable and practical to implement. So we've been, close with the BitVM guys, looking at other mechanisms. We're also looking at just Schnorr's cryptography, where we can upgrade to 1 of 1,000. Right now, we're 51 out of 100 today, and then we'll go to 501 out of 1,000, which in our opinion is like effectively decentralized. Our big thing is more what works where we don't sacrifice security, but are able to go to market and solve the customer's needs. So it's like the big thing that that's what's our approach been for the past couple of years.
Cool, I guess.
I can add on to like some of the challenges there. I think when I look at like bringing Bitcoin across multiple chains, one of the biggest challenges is going to be on liquidity fragmentation. And so let's take the example of SBTC, for example, because yesterday we had our latest cap increase. We've increased it to 3,000 BTC that are currently being utilized through the protocol. But when we look at actually bringing SBTC across multiple chains, it has to be interoperable with there's so many different wrapped assets and networks. And so how do we create a sort of unified hub of liquidity so that users can easily transact? And whether if you're going from SBTC to TBTC or WBTC, and we're able to make that process as easy as possible, and we don't end up with these fragmented pockets of liquidity, whether it's on Ethereum or Stacks or Solana or whatever chain you want to transact on, and ultimately abstracting that away from the user to make it as seamless as possible.
That's probably the biggest pain point. Going to different chains, like the gateways, how the tokens settle, how do you have like trustless tokens that are moving between systems? That's a good point. It's a lot of fun.
Yeah, I guess there are a couple of different like chain abstraction solutions projects trying to kind of solve that across the whole ecosystem. Well, maybe we want to shift gears a little bit. I mean, we only have 6 minutes left now. We wanted to have a couple of hot takes from the panelists. Maybe you want to briefly just give your hot take if you have one, and then subsequently maybe we can collectively decide where we want to dive deeper.
Looks at me for hot takes.
I mean, you always
now I need to figure out which one I want to say in this.
You only gave a few.
Look, I think sort of like I was on stage here just before the panel, and I think the one big message that I've been thinking about a lot is that we tend to think, I think, in the wrong terms when we're thinking about our industry, right? So we think about our industry as the blockchain industry, and we talk about chains, and we say, like, which layer are you? And the lower the number, the more valuable you supposedly are. And I think this is a completely wrong reading of what technology allows us to do, but also, and more importantly, of what value we're supposed to be bringing to the world. The analogy that I use is that us calling ourselves the blockchain industry would be like gold miners calling themselves the digging holes in the ground industry. Right? You're completely looking at the wrong side of you're looking at the activity, you're not looking at the value. Our value is bringing ownership to the world. We're the ownership industry. Bitcoin has proven to be the most reliable system for ownership, and that's the reason BTC is 3 times the size of all of crypto put together. And that's because the one thing that people really care about when it comes to ownership is that it's reliable, right? You really want your ownership to stay kind of remain. You want that asset to remain. And so I think there's a huge opportunity now that we've built out all of this infra, right? We've built out these different chains. We've built out these systems. And now with projects like Risk Zero, we have the ability to take all of that compute and verify it so it becomes legible. Like different chains will be able to see each other. And perhaps most importantly, Bitcoin will be able to see and understand what's happening on different chains and act as sort of like the final ledger, the big boss of our industry, providing its degree of security to everyone. And so what I think we're actually building, finally, after 15 years, is the Internet of Value, where if the old Internet, sort of the Internet of Information, the less valuable Internet, was sending IP packets from node to node, what we're going to be doing is we're going to be sending proof packets from node to node, proof packets from execution environment to execution environment. And so it's not going to be about chains, it's going to be about a settlement ledger, external compute environments like Meso, Stacks, and other L1s, and the ability to verify those proofs by projects like Risk Zero, to generate those proofs like projects like Risk Zero, and then verify them like projects like Bitcoin OS. I think on this stage, actually, we have the stack of the future.
All right, I'll take my hot take in a slightly different direction. And I'll try to keep it brief because I know we're coming up on time. But basically, the way that I see it right now is that there has been an arms race started to accumulate more Bitcoin, and we're seeing institutions and nation states and ETFs gobbling up all of the Bitcoin, and layer twos are a part of that. So as of today, there's about $30 billion worth of Bitcoin that is currently being deployed in layer twos, side systems, other sort of like wrapped tokens. That's just about 1% of the supply. And when we look at it, I think everyone on the stage is trying to activate the 99% of Bitcoin. And we're not just competing with each other, but we're also competing against the institutional wrappers. And I think if like, honestly, I think that we have to move faster, because if all of the Bitcoin ends up sitting in the Coinbase vaults and JP Morgan vaults, we failed as an industry. And so I think this is why we have to focus on self-custody, and all of these improvements, I think, are a big step towards that direction.
Yeah.
Here. I'm here for all of it. I mean, we are obviously our basically position is that, Bitcoin's security is the gold standard of security, and it will be the gold standard of security. We're just here to help you guys actualize it and bring it to market. And I think what's really exciting to me is that I know that it may seem at certain points in the Bitcoin space that everyone's doing their own implementation of bridging. It feels kind of chaotic, but it's also exciting because you guys are motivated by like this urgency to like unlock all of this liquidity and get it to the hands of the 99%, right? And I think that's what has always brought me back to like crypto after like 8-9 years. That's also still why I'm here. Like, I would love to see a future where everyone, including my great aunt who has never like heard of Bitcoin, has never held a wallet, is able to own a portion of that value capture. And I'm really excited to see, like in the BTC DeFi kind of things, like what kind of new innovations are going to be unlocked with this level of programmability, whether that's through the ZK stack, whether that's through like Stacks, and through, of course, teams like Bitcoin OS, Meso, Babylon. like, how do we kind of innovate more on the application layer and the consumer layer? Bitcoin-backed like loans is really exciting to me. Bitcoin-backed stable coins, I've heard of them, and I'd love to learn more about them if folks are here and are building in that direction. And yeah, like what are more consumer experiences, and how can we get people transacting in Bitcoin, holding Bitcoin, and using it and leveraging it in different ways? So I'm excited for that future.
Maybe Yogi can have a few
Yeah.
words.
I'll say my hot take kind of has been taken by most of this panel, but there's too many L2s. There are ghost chains. There's vaporware. We don't need more, but go ahead and build. I think just there's a lot. No, and then I think we keep focusing on the academic side and like how do we effectively decentralize. But I think to Andre's point, the fact that we have ETFs, no one's focusing on the consumer funnel and the consumer layer of why don't people use a wallet instead of going to Coinbase and buying. I think if we can solve that, this works. But I think for the foreseeable future, I think that Bitcoin's going to grow on EVM and like custody solutions like Coinbase more than it is on Bitcoin, and that's for us to solve. So
Yeah, I also think self-custody is super important, but I think it's can also be dangerous to oversee like the wrench attack, like just custody your keys at home. Maybe hybrid custody setup sometimes can make sense. Multi-sigs. So yeah.
I think like the big thing, at least, and you mentioned this earlier. The Bybit attack was through Gnosis Safe. Last year we had Ledger getting exploited through their signature schemes. So we can self-custody, but if there's 40, 50 attack vectors in it, I shouldn't have to worry that the package on my firmware that I got upgraded by a company that I don't control is being exploited. And that's why like you have cold storage with like big companies, and they have like there's just so many attack vectors.
That's why you want firmware, not software. You want a system which doesn't upgrade, which is Bitcoin.
Let's end it with that. Thanks a lot, everyone.
Thank you.
Yeah.